just because I feel like I want to make sure everyone remembers everything. So let's say we have a coordinate grid. Okay, just like in the XY plane. So this is 0, 0, right? That's our point, 0, 0. We have 2, 3, 4, 2. That's 1. My fault. Right? And let's say we have point 3, 2, okay? Now, if we want to express a vector, and let's call it A, that shows, this is point A, right? And we want to know how to get to point A. So the position vector of point A, which shows us how to get from the origin, 0, 0, to point A, 3, 2, would be expressed as vector OA, 3, 2. And of course, you can also do this if you want to go from a point to another point. So let's say we have a new point. Now point A is 0, 1. And this is actually point B. If we want to show how to get from point A to point B, we have vector OA and we have vector OB, which is now 3, 2, and sorry, that's really messy. And OA is 0, 1. So to get from from point A to point B, we'd have vector AB, which is OB minus OA. It's that one minus that one, right? And that vector is just 3, 1. Or sorry, yeah, no, there's 3, 1. And this can also be used to express the direction of a line that's going that way, right? But we'll get into that later because I don't want to drag on. And also vector AB is the exact same thing as vector negative BA, because keep in mind the direction does matter. So if we're going this way, we can't just go this way and say that it's the same thing. Not allowed. And if we have some kind of line segment like AB, and we want to find how long it is, so we want to find the length of, sorry, it's getting really messy. We want to find the length of this part, right? We can get the magnitude of AB, which is just the square root of the components. So here it would be the square root of 3 squared plus 1 squared. So think of like Pythagoras or complex numbers or whatever else. So that's the square root of 9 plus 1, which is square root 10. And that's it, right? And sorry, what's going on? Are people asking questions? I got a little bit distracted. We're just doing vectors, that's it. Okay. Anyway. Also, you can add vectors together. So, okay, wait, I'm going to draw a new grid because that one's getting a little bit... Yes, planes. Yes, planes. Planes are part of vectors. I'm going to erase all of that because it's getting really messy, and we're going to draw another chart, okay? So, we have 1, 2, 3, 4, 5, and 1, 2. That's not properly spaced out. 3, 4, 5, 0. That's all. Now let's say we have point A over here. We have point B like here, and we have point C like over here. So not today, Jad, not today. So A is 1, 1, B is 3, 4, and C is 5, 2. And now a fun thing you can do is you can add vectors. So for example, if I want to get from A to B, I can do it like that, but I can also do it like this, right? So AB is also AC plus CB. right? And in the same breath, you can do it in any direction. Now, I'm not gonna do this with numbers because honestly, I'm trying to get through this as fast as possible, and I don't have time. But you can do that, right? Because I'm assuming you guys already know how to do this. And of course, if you have a vector a and you multiply it by a scalar, so any number, it gets 2 times. So if I'm multiplying it by 2, you're multiplying every single component by 2, so it gets 2 times bigger, right? That's not the scale. But you get the point. And then also, before I start doing any questions, here's a really big reminder on notation. Okay? First of all, if you have a position vector of a point, you can call it OA or O whatever. What is this template? It's my template, okay? And that's just X, Y, Z, or oops. Or you can express it as xi, or I'm gonna use a because no, it's fine. Xi plus yj plus zk. And I is a unit vector that goes in the positive x direction, j is a unit vector that goes in y, and k is, that doesn't matter, but you can express it either way, okay? And also, if you have a line L1 and you want to express the equation of the line, you cannot do this. Don't do this. It shows like a complete error in understanding and you're going to lose marks. So you want to put a colon there, and then R is it expresses the equation of any point on that line equals whatever line you have, x, y, whatever point you have, x, y, z, plus lambda into whatever other x, y, z you have. Right? Make sure that colon's there, or you're going to lose marks. Same things goes for planes. If you have a plane pi, you cannot do, this is HL. You can't do plane pi equals AX plus BY plus CZ equals D. You're going to lose marks right there. It's a colon, right? Because this isn't expressing the plane, it's expressing any given point on the plane. So please make sure you do that, or you're going to lose marks right off the bat. And you don't want to do that, right? And another point, can you do an equal sign but with 3 lines? No, because, I mean, actually, I guess you can. I've never seen that. I just use a colon. But sure. Pi is a plane. That's a vector plane. I mean, I personally have never seen that notation, so I'm not going to call that. But I'd say just use a colon. Maybe you can ask Andrew. I've never seen it. I don't think it completely makes sense, but notation for unit vector, I mean, if it's a unit vector, you can just, because it's a vector, you're just expressing the vector. There's no like specific notation. Usually I just see it as U, and if it's on a textbook, then it's usually bolded. You can just put an arrow above it. Right. Also, another point. If a question asks you for a coordinate, let's say the coordinates of point M, you can't do this. That's wrong. You're immediately getting marked down for that. You're not allowed to do that because you're giving them a colon vector and they're asking for a coordinate. So you have to express it like this because it's a coordinate and not a vector. Make sure you remember that. See, you get. So that's another important point you have to note. And then also, just really quickly, remember that there's multiple ways you can express things, right? If you have a line, you can express it as R equals whatever the hell point. Let's just say OA plus lambda into the direction of the line, right? Or am I muted? Okay, great. Anyway, or you can express it in parametric form, so x equals a plus b lambda, etc., or in Cartesian form, so x plus a over b equals lambda, and then that goes for the rest of the variables, right? Same things with a plane. A plane can equal OA equals OB plus lambda OC into mu OD, and that's that. Or you can have it in Cartesian form, so AX plus BY plus CZ equals D, or in scalar product form, so N dot R equals A dot N. Right. And unit vectors are a thing. I feel like I haven't talked about those. It's basically just a vector to go one unit in any given direction. So its magnitude is always 1. And if you have to find the minimum distance between things, the minimum distance is the perpendicular distance. So they're asking for that, right? And we know that when two things are perpendicular, it means that the dot product is 0. Yes, I can. So basically, it's the same thing as this equation, but just written differently. Because imagine you're finding the Cartesian equation of a plane, right? N dot R, this just means the equation for like any given line on the plane, which is x, y, z dot the normal, right? So this is just dot R normal. And then A dot N, A is a known point on the plane. So it's the point that we already know, right? That's the one that we're using to find it. And then N is our normal again. Does that make sense, or do you want me to like actually work through it with numbers? When we have a plane question, I don't mind like working through it with like some actual numbers to show you what I mean. But does that make sense a little bit? N is the normal, and R is any point on the plane. Just any point that lies in the plane. Draw a diagram of what? R is any point that lies in the plane. A is a known point in the plane. So we know what A is, and then R can be anything that's in the plane. Well, we can't skip it because someone asked about it. Be nice. And also, please draw a diagram every time you do a question, or you're probably going to mess it up. That's like top 10 ways to make sure you're good at vectors. Just draw out the question. And thank you. And I'm going to start doing questions because I'm sick of this. We're going to start easy. We're going to start with a nice chill question. Now, do you guys want to actually try the questions, or do you want me to just start working through them straight away? Because I'm not, just do them, or do you want to try them? Okay. You know what? I'll give you like. Okay, the majority seems to want me to just start working through them. How do you find the line that goes through two planes? I'll get to that. But basically, because do you mean like two intersecting planes? When you have two planes that intersect, right? That's a really bad drawing, but when you have two planes that intersect, we have N1 here, so we have the normals of both planes, right? And we have a line that goes through both of the planes right here. And so what you'll notice is that the direction of this line is actually perpendicular to both of those normals, right? It's perpendicular to this one, it's perpendicular to this one. So what you can do here is just find the cross product of the normals, and that'll give you the direction of the line. Also, you can do this other thing where you like use row reduction, but not row reduction. You can, you can equate one of the variables to lambda, but this is like a pretty surefire way to get it if you already have a point that's in the two planes. Anyway, sorry, I got sidetracked. Let's do this. Now, this is pretty nice. This is pretty simple. And the first thing I'm going to do is I'm going to draw it out so we don't get confused, right? Because you will get confused at some point. I mean, you probably won't, but because this is a pretty simple question, but as a good rule of thumb. So let's just say we have this, right? So we have A, which is at 0, -1 over here, and we have B at 2, -3 over here. So if we want to find the position vector of the midpoint of AB, honestly, the easiest way to do this is to just find the midpoint and then express it as a vector, because the midpoint is just these two added and divided by 2, and these two added and divided by 2. So the coordinates of the midpoint are just 2 over 2 and -4 over 2. So 1 and -2. And we can just express that as like OM equals 1 minus 2. So that's as a vector. Right. And I missed one. Oh, oops. Well, can we just pretend it's there because I don't want to redo it? I'm telling you guys, I know how to do the vectors. I just can't do the really easy stuff, like remembering how to count. So we're just going to ignore that. Yes, I'm sure. Anyway, now we want to find the position vector of this point called D, which divides AB and, well, no, because it's not 3 minus 1. We're finding the midpoint. So you add them together and then you subtract, and then you divide it by 2. Right. So we're trying to find point D, which divides AB in the ratio of 1 to 2. So what does that mean? That basically means that we're trying to find a point that divides this ratio where this is as big as 2 of these, right? So whatever OD equals, it has to be able to get to here, right? And we can do that by doing OA plus a third of AB. Can you guys tell the dude that if he can't hear it, he should just leave and rejoin? I don't know what he's doing. Anyway, that's how you can find OD. Do you get why that works? AB is did we haven't found AB yet. Slow down. But do you get why this is OD? Like, do you get why that makes sense? Okay, great. And so we can just, oh my god, what just happened? We can just work through that. So OA is 0, -1, and no, I didn't. And AB is, well, if we have vector OA to be, yeah, 0, -1. Oh, oops, I did label it wrong, but we're gonna pretend I didn't. Can you just pretend like I didn't? I did label it wrong, but we're gonna pretend I didn't because the point is the approach, not the actual diagram. Anyway, it's a third because if we're dividing it in a ratio of 1 to 2, one of these has to be equal to 2 of these. So then it's going to be going a third of the way, if that makes sense, right? Like, say we have, oh, does that make sense? Okay, great. No, it is labeled wrong, but we're just gonna ignore that, okay? Like, there's too many of you guys watching me. It's stressing me out. And if we have OB, which is 2, -3, then AB is just that one subtracted by that one, so that's 2 and -4. That's the question. So we have 0 minus 1 plus 2 over 3, -4 over 3. And you can work that out, but I want to move on, so I'm not going to work it out. But that will give you the right answer. What do you mean are we calculating AB? You can find AB by doing B minus A. This is the midpoint of AB. So we have to find AB itself. But AB is just 2 times the midpoint, actually. I did just find it the normal way, though. Can we move on? Does everyone get this? Why would it be -2? Oh, it is -2. Wait, you're so right, actually. My fault. My fault, my fault, my fault. I can't do basic arithmetic, guys. What did I tell you? I understand the approach. I just can't do basic arithmetic. Anyway, can I move on? Do you guys get why that works? Okay, great. So this is one of Andrew's questions off of his mock. And I think it gives us a fun little reminder of how the dot product works, because remember that the dot product is commutative. So if we have A dot B, it's the same thing as B dot A, and it's also distributive, which means that if we have A dot B dot A, or C dot D or whatever, it's A dot C plus A dot D, right? Commutative just means that this is the same thing as this. Like, it doesn't matter what order it's in. That's all it means, right? Yes, I meant C plus D. Thank you, Jeff. C plus D. Yes. You can't do that. You can do that. So you can distribute it. Let's say you have A dot C plus D. It's the same thing as A dot C plus A dot D. That's only for the dot product, though. When it asks you to find the acute angle, how do you remember what to minus the final angle from? It's always 180 minus. Yes, you can see the question. So here we have 2 vectors, and we know that the magnitude of u is 4 and the magnitude of v is 5. And we know that u dot u plus v is 21. And we know that the acute angle between those two is theta. So we have to show that cosine theta is 1/4. Oh, well, for a plane and a line, it's 90 minus the angle, because when you have a plane and you have the normal to the plane, and then you have a line that's intersecting the plane, this is our line, the angle between the line and the plane is 90 degrees minus the angle between the direction of the line and the normal to the plane. Because we use the normal to the plane to find the direction between the line and the plane, if that makes sense. That's why it's 90 minus. Do you get that? Well, until we get a clear answer. Oh, okay. Okay, great. Sorry, I'll go back to the question now. So we have these vectors. And because we know that the dot product is distributive, we can do this really fun thing. So u dot u plus v is equal to 21. So it's u dot u plus u dot v equals 21. And another fun property of the dot product is that u dot u is the same thing as the magnitude of u squared. Plus u dot v equals 21. Do we know why it's the magnitude of u squared? Do I have to explain that? We do know. Okay, this is AAHL. Okay. So then that just means that it's 4 squared. So 16 plus u dot v equals 21. So u dot v equals, I can't do mental math. Anyway, that's 5. So we've gotten this far, and now because we know this, and because we know how the dot product works, we also know that 5 equals u into v into cosine theta. And we have to show that cosine theta is 1/4. So 5 equals, what was u and v? 20 cosine theta. So cosine theta equals 5/20, which happens to be 1/4. So that's our answer right there. And now we have to find the area of the triangle formed by u and v. Do you guys know how we're going to do that? Yes. Let me check, Trev. Well, it's not exactly the cross product, but it is the cross product. Like, because remember how you can express the dot product as u like magnitude of u times magnitude of v sine theta. That's how you do it. Is acute angle always found by a dot product of vectors? Well, I mean, yeah. Just yeah. And if you get a question, I mean, if you get an angle that's bigger than 90, make sure to subtract the value so that you get the acute angle, because the angle between two lines has to be the acute one, not this one. Has to be that one. This is, you can't even do this with a calculator. But anyway, we're going to find the area of the triangle now. So we know that the area of a triangle is half the magnitude of u cross v. And we also know that u cross v is the exact same thing as this times this times sine of theta. Between two lines, it cannot be the big one. It has to be the small one. It's got to be the small one. Yup. Anyway, we're going to keep doing this, right? So the area is half of this. So A equals half of 20 into sine theta. Which I don't want to deal with. Paper one is real math. I mean, Loki? Fair enough. Paper three is like even chiller though, honestly. I love paper three. Also, well, is it? No, it's not. Not quite. But anyway, first thing we need to do is actually find sine theta. I like forgot about that. And so we have to do that first. How did you go from, this isn't the dot product, this is the cross product because it's sine. So that's how I got there. Right, does that make sense? Yeah, of course. So if we want to make it easier for ourselves instead of doing that, we can do it that way. So it's just 1/2. We have u and we have v, that's 20. That's 10 into sine theta. But, and then we need to find the magnitude of that. Is anyone recording this? I'm pretty sure Gabs is. So yeah, no worries. But anyway, I'm actually doing this wrong. My fault, guys. Where's the recording gonna be posted? Probably in the math channel. I'll pin it. So we should be all good there. Could you share the sheet you're in? I mean, if I don't erase everything, I'll share it. Just in case you guys want it. How did I go where? Because that's the cross product. Wait, guys. 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 Where's vectors in the formula booklet? It's in the formula booklet, guys. It's okay. How can a non-scalar thing be an absolute value? Because you're finding... Oh, oops, my fault. Oh yeah, no, it's not half. I put the extra half there when I was saying that it's the area of a triangle. What do you mean, how can a non-scalar thing be an absolute value? Because it's not. It's the magnitude of it, not the cross product itself. It's the magnitude of the cross product. It can be a negative because you're multiplying it by sine theta. Does that make sense? There's nothing wrong with questioning mathematics. They can question mathematics if they want to. No shame in it. Yeah, it's the magnitude of the cross product is the area of a parallelogram. So the area of a triangle is just half of that. Does that make sense? Okay, lovely. What's the final answer? Don't you want to work it out yourself? Can't just spoon feed you everything. Well, you were almost there. You were really close. Maybe you just simplified the fraction wrong, honestly. No, you're not. Guys, I do want to let you at least try part B by yourself. Yep. Okay, guys. Can I go through it now? I'm gonna take that as a yes. We know that sine squared theta is equal to 1 minus cosine squared theta. So we can do that. We can do that. Sine theta is equal to the square root of 1 minus 1/4 squared. Right? So that's the square root of 4/4 minus 1/4. So square root, wait, no, that's 1/4 squared. Sorry, guys. So that's actually 1/16. And that's 16/16. So we have 15 over, or no. Anyway, 15/16 square rooted. So we can write that as root 15/4. That's our sine theta. So now we know that our area is 1/2 of 4 into 5 into root 15/4. That goes away. So that's 5 root 15 over 2. Units squared. Don't forget your units, guys. Does that make sense? You do need to write units squared. Don't do it. You might lose marks. If there's no units, write units squared. Why can't we use the triangle method? What triangle method? You are using the number it asks you to prove. Right here. Cosine theta is 1/4. What do you mean right angled triangle? Sorry, I don't know what you're talking about. Well, why would you? This is the Pythagorean identity, though. I'm questioning your approach a little bit. It's basically the same thing. I mean, sure, but why? It's the same thing. It's the exact same thing. I'm gonna move on. Okay, this is a fun little easy one. We have our point A, 3, 1, minus 2, and our point B, 4, 0, 3. If we want to find the equation of a line passing through both of these, we need to find the direction of the line. And the direction of the line is the same thing as vector AB. Yep. Ahead of the curve, bro. Calm down. So AB is 1, minus 1, 5. And we can just use this as our fixed point. So then L is equal to R. No, sorry, L colon R is 3, 1, minus 2 plus lambda into 1 minus 1, 5. You don't have to use lambda. You can use t or whatever variable you want. Yeah, all good. Doesn't matter which point you use. So that's a nice chill one. That's a fun little simple one. No worries there, right? Does it matter where the... I mean, you want to put the fixed point first. I guess it doesn't matter, but why would you? Also, you could do another equation. You can do another form of the equation. You don't have to. 1 second, guys, I'm getting a call. Okay, anyway, my fault, guys. Fixed point, it's a point that you already know that it's on the line. So, yeah, that's it. No worries at all. The fixed point is not the midpoint. Also, I mean, it doesn't really matter what you use as your fixed point. It's just any point on the line that you know is there. That's it. So can we move on now? Everything good? Okay, great. Now let's do a plane question. So we know that if we have a plane, we can define it by 2 vectors inside the plane and a point that we know is in the plane. Right, that's just planes. And now here we want to find the equation of a plane that passes through point M and is perpendicular to the line NP, which passes through these points. Okay, guys, let's think about it. How do we know the normal to this plane? It's actually really simple. Exactly. Exactly. I mean, you want to make it into nicer numbers so that they're not like Cancer to deal with, but yes, that's the gist of it. Do you guys get why vector NP would be the same thing? Well, the midpoint is the middle between two things. So if you have A, B, and you have A here and you have B here, the midpoint is the middle. That's the midpoint. But if you have a line, a fixed point is just any point that you know is on the line. So A, that's my fixed point. I know that it's on the line. Well, I'm yes. If you have two fixed points, you can find the midpoint between them. But the two concepts are unrelated. Yeah, okay, anyway. Do you guys get why the normal to the plane is the same thing as NP? Or it goes in the same direction as NP? Yes, we do. Okay, I'm gonna draw it anyway. Because I think it's a good rule of thumb to draw things. If you have a line, NP, and you have a plane that's perpendicular to it, so this is 90 degrees, the normal to the plane is going to be going the exact same direction, right? So it's a scalar multiple of that direction. So now let's find, and we already have our fixed point right here. So NP is 2, -2, -4. Let's make that nicer. So I'm going to multiply it by -1. So that's -2, 2, 4. We're going to make it even nicer. I'm going to divide everything by 2 just because I want this to be like a tolerable equation to work with. So -1, 1, 2. That's our normal. Yeah, you can only do this because it's expressing the direction of the normal. So now, because we have the direction of the normal right here, we know that -x plus y plus 2z is equal to d, and we can find d using the point we already have. So -3 plus 1 plus 2 times 2 is equal to d, and that's -3 plus 1 plus 4 is equal to d, so that's 2. So put 2 there. There's your answer. All good? Make sense? I'm just going to move on for now. Plug in plane point into direction vector of NP. Well, in the Cartesian equation of a plane, that's where you put in the point. Yeah, that's the same thing. All good. I just divided it so that the numbers would be a little bit nicer. Oh, wait. Wait, is it the same thing? Yes, it is. Sorry, I was working with different numbers. All good. You're fine. Okay, we have another fun one. The angle between a line and a plane. Now, I already mentioned this, but you have to watch out for the wording here. So we have a plane pi that has the Cartesian equation x minus y plus pz equals 10. And line L has vector equation this. Exactly. So if we have the angle of the plane between the plane and the line to be 30 degrees, we have to find the value of p. So we know that we can find that using the dot product. But what we have here is the normal to the plane. P is part of the normal to the plane. And the angle between the line and the normal is actually 90 minus 30, which is 60 degrees, right? So now we have the direction of the line, which is 1, 1, 1, and we have the normal to the plane, which is that. So we can work this out, right? First, let's just find the dot product. So 1, 1, 1, dot 1 minus 1 p is equal to 1 minus 1 plus p, which is p. Okay, that's pretty nice, isn't it? And then we know that that equals the magnitude of 1 squared plus 1 squared plus 1 squared times the magnitude of 1 squared plus negative 1 squared plus p squared. Right? Into cosine of, what's it called? 60. So now p, that's square root 3 into 2 plus p squared under the square root, sorry. Into cosine 60, guys, what's cosine 60? Jeff, not quite. Guys, come on, we remember what cosine 60 is, right? Can't do everything myself. Exactly. You're almost there. Remember the condition. P's smaller than 0. Have to pick the negative one. Just to clarify, only plane and vector. Yeah, if you have a line and a plane, that's the only time you're doing the 90 minus thing. Because of you're finding the angle between the normal. The angle is 60 and not 30 because it's the angle between a line and a plane. Well, no, you can't use sine because this is the dot product. Jeff, negative, but yes. But, buddy, what? I mean, sure, but no. This is just simpler. I don't know what you're on about. You can't just, cosine 60 isn't the same as sine 60. If you absolute the, well, if you absolute value, well, yes, you can use sine 30, but if, no worries, thank you. You can use sine 30 if you want to, I just don't want to, because I don't want to do mental gymnastics and accidentally mess up a question. We're trying to make our lives easier, not harder. Yeah, I'm gonna keep working on this while you guys ask stuff, because you're confusing me. Right, anyway, I'm gonna multiply by 2 because I don't want to deal with that. 2p equals square root of 6 plus 3p squared, right? Now we're gonna square both sides. 4p squared equals 6 plus 3p squared. Subtract p squared, sorry, equals 6. So p equals plus or minus square root 6. And we know that p has to be less than 0. So this one gets rejected. P is negative square root of 6. That's how you do it. Any questions? Everyone reads the question, guys. Top 10 ways to mess up is not reading the question. The amount of times I fucked up a question because I didn't read it properly. If it's a planar line, well, I mean, yes. Think about why. If you have a plane here, you have the normal to the plane N. You have a line that's intersecting with the plane L. If you want to find this angle, but we're working with the normal of the plane, if you use the dot product, you're actually going to get this angle. So if you want to find that angle, you have to do 90 minus that one. That's why. Make sense? All right, no worries. P is negative root 6. Do you get why? um, all right, guys, I'm gonna take that as my cue to move on. If anyone has any questions, I'll answer them, of course. Here's a fun one. I want you guys to. You don't have to do the whole thing. I want you guys to at least think about trying it yourself, because there's a little bit of mental gymnastics here. You have two planes, pi 1 and this is good notes. You have pi 1 and pi 2, and you want to find the equation of a plane that passes through this point and is perpendicular to the line of intersection of pi 1 and pi 2. And it's also perpendicular to this plane. There's a lot going on there, but okay, try it yourself. This one's a fun one. I want you guys to actually give it a go. I've been doing all of them straight away. Just give this one a go. Give it a chance. It's a lot simpler than you think. And if you have any like assorted questions, I'll answer them while you guys figure it out. Any point on the plane will be perpendicular to both of the plane. What do you mean? This plane is perpendicular to the line of intersection of these two planes. What do you mean vector sum formula? Buddy, sum formula? Buddy. Okay, sorry. Here's the cross product. Here you go. Oh, sorry. Wait, let me. Oh, okay. I'll let you guys get a little bit longer. Yeah, all good. Is anyone still working on it? Yeah, no worries, no worries. I won't start right now. Don't worry. It's actually a lot easier than you think it is. What do you mean second direction vector? Yes. Draw it. Draw it. What form does the equation have to be in? Well, I mean, you can either do scalar product form or Cartesian form. It's a plane. It doesn't really matter. Ooh, that's a fancy way of expressing it, Jeff. Should be right, I think. But why wouldn't you use the Cartesian form? Buddy, use the normal to the plane. And then you put in a point. That's all. You don't need to find the intersection because you don't actually have to find the equation of the line. I mean, you can if you want to, but you don't actually have to. Or actually, you might have to. You might have to. I've been zoning out a little bit. Buddy, slow down. You need to yell at me. Oh, no, you don't have to. Never mind. You don't have to. Because you already have the point that's in the plane. Is anyone still working on it, or should I go through it? Is anyone still working on it, or should I go through it? All right, great. So the first thing I'm gonna do is draw it. I'm telling you guys. We want it, so we have a plane pi1, and we have a plane pi2, and they're intersecting at this line. And we want a plane, I'm running out of colors. We want a plane that's perpendicular to this line. So it's, how do I even draw that? It's like, it's perpendicular to that line, except I'm good at art, just not this art, so bear with me. But it's perpendicular, okay? But we don't want it to be perpendicular to that line. We also want it to be perpendicular to this plane right here. I'm gonna assume you're right. I did it in Cartesian form, but I'm gonna assume you're right. Maybe Jeff, can you check it? Thank you. Anyway, think about it, guys. We doing HRSL? This is HL content. Right? Anyway, so that means that the normal of the plane has to be perpendicular to the direction vector of the line, but it also has to be perpendicular to this plane. And when two planes are perpendicular, that's a horrible drawing, but when two planes are perpendicular, so are their normals. So the conclusion to this whole mental gymnastics session is that the normal to our plane has to be the cross product of the direction vector of the line and the normal to this plane. And the direction vector of the line is, I'm not going to go through it because I'm lazy, but you could just find the cross product of these two. That's going to give you 13, 10, 1. Now we're going to cross it with this normal, which is 1, 2, 0. The thing is, I do the cross product different than how it's done in the formula booklet, and I don't really want to confuse you guys. So I'm not sure if you guys actually want to see me compute this. I do it with the determinant, yes. But I'm not going to teach you something new like right before the exams. You can do it. No, you can do it the way it's done in the formula booklet. Nothing wrong with that. I'll work through it the way I'm used to, but please just ignore it if you don't know how. We don't have to learn new concepts. Right. Yes, Jeff? Yes? Because it has to be perpendicular to that plane and it has to be perpendicular to the line. So it has to be perpendicular to both of these. And its normal will be perpendicular to the normal of the other plane. What? No. Guys. This is the normal to the plane. Guys. Guys. If we have two perpendicular planes, here's my other very badly drawn plane, and they're perpendicular. Their normals are also perpendicular. And because we want it to be perpendicular to this, and we want it to be perpendicular to that, we're going to have to cross this one and that one to get the one we want. Do we get that? Wonderful. Except, wait. Oh, I messed up something here. My fault. So, the normal to this plane is -1, -2, 16. I don't like that, so I'm going to multiply it by -1. So 1, 2, -16. But it actually doesn't matter. Right, so now we can write the Cartesian equation of a plane as -2x. Oh, sorry. Negative, it's x plus 2y minus 16z equals d. And we know that it goes through this point, 8, 0, 1, so we can substitute that in. So 8 plus 8 minus 16 is d. No, sorry, wait. 8, 0, 1. I think I should be 2 and j is just 1. You might be right. I might have computed it wrong. Sorry. Did I compute it wrong? Oh, no, it's not negative. There we go. It's not negative. I can leave it like that. Sorry, guys. Double negative. Canceled out. Don't be like me. Yes, I can show you the question. Sorry. Just let me just do it. So negative x plus 2y plus 16z equals d. And we know that this point is here, 8, 0, 1. So negative a plus 2 into 0 plus 16 is... That's wrong. Wait. I'm not getting the answer I want. Oh, this is 2. Guys, I crossed them wrong. I crossed them wrong. Hold up. My sincerest apologies. What you want to be, well, until I figure out what I computed wrong, what you want to be getting is -2, 116. I crossed my vectors wrong because I wasn't paying attention. Oh, I know what I did wrong. Sorry, guys. There we go. All good. My fault. So we're going to get -2x plus y plus 16z is equal to d. And we know that point E01 is in the plane, so negative 16 plus 0 plus 16 is equal to d, so therefore d is 0, so this is the equation of the plane. Sorry for that little fuck up. Do we understand why that works, though? And here's the question. Thank you, Paradigm. Parallel to the line. Thank you, Paradigm. From Andrew's vectors unit test. You can find it on Andrew's website. I didn't do it without the line of intersection. The direction of the line of intersection is this normal crossed with this normal. Patrick, that's the direction of the line of intersection. Yes. Yep, yep, yep. Good night, Jeff. Sleep well. Is everyone fine with moving on, or are there any more questions? Because I want to make sure everyone gets it. What do you mean, which plane? This is representing the normal to this plane that we're trying to get. This is HL vectors. I mean, we are doing a full rundown of vectors. This is like most of the topic. Obviously, some stuff I won't have time to cover, but I'm trying to cover as much content as I can. I don't get what you mean. Cool. This is the line of intersection of two vectors. It's just where they intersect. That's it. Right there. There's a line there. It's like if hypothetically I get a piece of paper and I cut it and I put another piece of paper in there. There's a line. That's the line. Do you guys think we can move on? Perfect. Also, guys, I don't think I do cover it in these questions, but do remember that the mixed product is a thing. So you can have something like A dot C cross D. That's going to give you the volume of the parallelepiped, or the box. I like to call it the box. That's going to give you the volume of the box. Because remember that volume is, yes, it's in the spec. Yes. Volume, yeah, guys, calm down, calm down. It's in the syllabus. It's 100% in the syllabus. It's very simple. We know that the magnitude of the cross product it's always been in the syllabus, guys. Don't worry, don't stress out. This isn't the question. There's no question right now. I'm just telling them that the mixed product exists. A cross B, the same thing as the area of a parallelogram. Okay? If we bring this parallelogram into the third dimension, horribly, because I don't know how to draw that. we're doing the same thing as u cross a plus b. U dot a cross b. Because that's height times cross-sectional area volume, right? And yes, the mixed product is in the... Is it taken out? I swear I've seen it in questions. Really? I mean, either way, I feel like it could show up as like common sense kind of thing. No? I mean, they could ask you to get it. Either way, okay, guys, never mind, never mind. I guess it's not in the syllabus. My fault. I learned it in class, so I assumed it was. It's not difficult. It's not difficult. I promise. Anyway, there's no vectors in SL. What do you mean, teacher? It's just the... you just times it by the cross product. Oh, Lord. Anyway. We have points A, B, and C. And we have a plane pi that contains those 3 points. First thing the question is asking us to do is find the column vectors A, B, and AC. I think that's pretty easy. You got AB is -2, 2, 2, and well, unless you guys want to do it yourself. This is some light work though. AC, we got 2 minus 1, 0. Like, this is direction vectors. This is light work. I'm not making you sound dumb. Come on, it's come on. Come on, it's just that minus that. We got it. All right, now we have to show that this vector 2, 4, minus 2 is normal to the plane pi. And we know that... Wow, that's beautiful, Beetle. And we know that vector AB and vector AC are inside the plane because they just told us that they're inside the plane. So, if we want to show that this vector, is normal to the plane, a column vector is just a vector that's expressed like this. This is a column vector. Like that. Right, anyway, if we want to show that this is normal to the plane, how do we do it, guys? It's expressed like that because it's in a column. Yes, cross product. Now, I'm not actually going to do it because I don't even do it how you're supposed to. Or I don't do it the way that's taught in the syllabus, and also it's gonna waste time. But all we gotta know is that 2, 4, minus 2 is normal to the plane. If you guys want to do it, feel free. I'm not doing it. Hence, show that the Cartesian equation of the plane is this. So what do we have to do? Yes, I'm not being lazy. I'm saving time so you guys don't have to sit here for 2 hours. Exactly. So 2x plus 4y minus 2. Well, actually, I'm going to make this simpler. So x plus 2y minus z is equal to... we have to put in one of the points. Which one should we choose? 1, 0, minus 1. So 1 minus minus 1 equals d. D is 2. There we go. That's how you get the Cartesian equation. What part are we on? We're not... I've covered most of the syllabus, I think. We've done intersection between a line and a plane. Not intersection, we found the angle between a line and a plane. Plane that's perpendicular to another plane. Line between 2 planes. Just the vector equation of the line. I can do more vectors if you guys don't get them, but I feel like I've covered a decent amount of the syllabus. But yes, I can do more vectors if you guys want to do more vectors. Probability. Oh, someone else is doing probability. I think Andrew's doing that. Sorry, I read that wrong. I think Andrew's covering probability because none of us want to do stats. Well, Andrew's not here right now. Anyway, we have a point D. Guys, I don't know. I don't have it memorized. There's a lot of math revision hosts. There's a lot of us. Anyway, we're going to stick to the question. We have a point D that's not in this plane. He's a grown man. Write down the vector equation of a line that goes through D and is perpendicular to the plane pi. Notice how it says write down. Notice how it's 1 mark. This is really simple. How do you do it? Exactly. So L R is 3, 1 minus 3 plus lambda into 1, 2 minus 2. There we go. Simple stuff. Now, here's a fun one. Point D is reflected in the plane. Yes, 1, 2 minus 1. Sorry, Patrick. I can't divide. I'm not putting Subway Surfers gameplay up. Okay. Let me draw it. No. Anyway, let's say you have a plane pi. Yes, pretty much. It's like it's a mirror. So, and you have a point here. Point A is reflected in the plane, so it's like ends up there. And it's the same distance from here to here, and that's like that. So, thing is, there's a really easy way to do this. What we want to do is we don't actually want to find the distance, we want to find the coordinates of this point right here. So for our example, we actually have point D, we have plane pi, and then this reflected point called E. That's what we're trying to find. And for our sake, I'm going to take this little intersection right here, and I'm going to call it N. No, wait, we already have a normal. I'm going to call it G. So if we find point G, which is where this line that we just found intersects the plane, we can find point E because we know that it's the same distance away, right? How can we find point G, or the intersection of this line that we just got and the plane? Yes, use the parametric equation of the line. Well, not Cartesian, parametric, but yes. I guess you could use the Cartesian equation. No, wait, no, you couldn't, because you have to look for lambda. Anyway, we have our line right here. X equals 3 plus lambda, y equals 1 plus 2 lambda, z equals negative 3 minus lambda. Okay, so now we're going to put those back into the equation of the plane, and pi equals, what was it? X plus 2y minus z equals 2. Also remember, you have to put a colon here. Ignore me saying pi equals, that it doesn't equal that. And we know that x is 3 plus lambda plus 2 into 1 plus 2 lambda. This isn't to find distance, this is to find the point of intersection between the line and the plane. Oh, thank you, Patrick. Negative 1? What do you mean negative 1? What are we talking about different things, guys? calm down. Anyway, minus -3 minus lambda. Oh, you're right, but slow down. The questions from before, a lot of them were from Andrew's mock exam, or not Andrew's mock exam, Andrew's unit test. I can send it. I can send the link for it on the math channel. And then this is actually from Revision Village, so I can't share that. We take the parametric equation of line, we put it into the plane, and then we find lambda, and then we put lambda back into here and get the point of intersection. So let's work through this. 3 plus lambda plus 2 plus 4 lambda plus 3 plus lambda equals 2. So that's 6. No, that's 8 plus, what, 6 lambda? 6 lambda equals 2. So then 6 lambda equals -6. Lambda is -1. Put it back into here. So x is 3 plus -1, so that's 2. Y is 1 plus -2, so that's -1. Z is -3 minus -1, so that's -2. So this is these are the coordinates for point G, or our point of intersection that I named G. And now we can use this to find point E, which is the reflected point in the plane, because we know that dg is equal to GE, and we can use that to find E, because GE is the same as OE, which is the one we're looking for, minus OG, which is the one we just got. Right? And so, well, actually, first we have to find vector dg. Sorry, I skipped a step. First, we have to find vector dg. We have vector d, and we have point d, and we have point g, so we can do that. What was point d, guys? 3, 1, minus 3. So that's 3, 1, minus 3. No, wait, what was g? 2 minus 1 minus 2 minus 3, 1, minus 3. Bear with me. What was the point being reflected? D. That one. So that's -1, 0, 1. That's dg. Or unless I can't count. Sorry, Patrick. What do you mean, and the question is solved? What do you mean 246, buddy? Oh, you've done it already. It's not 246. I don't know where you got 246 from. Anyway, we have vector dg. We can use that to find OE, which is the one we're looking for. So dg, which is -1 minus 2, 1, is equal to what? It's equal to GE, which is the same as OE minus OG, which we already have, 2, -1, -2. So E, or OE, is 1 and -3 and -1. You put them in the wrong order, Patrick, but sure. And keep in mind, it asked for coordinates, so I can't express it like that. E is 1, -3, -1. I have to express it that way. That's the whole question. No worries. No, this is important. Oh yeah, that too. Thank you, Paradigm. It's minus -2. No worries. Oh, that's some lovely handwriting. No, it's not like that. I don't know how you got that, Patrick. It's 1 plus -2, so you'll get -1 at the end. Good point, Paradigm. I just didn't think of that. Thank you. Well, in this case, yes. Because if we know that when lambda is -1, we will get, because if we're going along the line, if we know that when lambda is -1, we're here, then when lambda is -2, we should have gone twice the way down, which is why this will correspond to E, so you can do it the way that Paradigm said so. I just thought it'd be good to visualize it. But yeah, exactly that. Any more questions on this, or do we get everything? So I think I have one more. When's the next math revision? I don't know, because I'm not hosting that one. Unless I am. I don't know. Is there anything scheduled? This is the reflection of the plane. This is a point reflected in a plane. I don't know what you mean, Patrick. You can click that you're interested on it in the events tab when it's scheduled. No worries. Oh, well, no, not today. I don't know when you'd ever, yeah. I mean, or you could just have a line that's reflected in a plane, in which case you're just gonna get a line that's that way. Never seen a question with a plane reflected in a plane. But maybe that exists. No, I'm sure it's a thing. Do we need to know how to find the minimum distance between lines? I'm glad you asked. I can find a question like that right now. Would you like me to? Or actually, to save your guys' sanity? Oh, or you do want an actual question on it? Okay. 1 second. I got you. I think it's a paper 2 question, but it's okay. They do this with intersecting lines. Minimum distance. No, no, no. Well, yes. Not with intersecting lines. You would never have minimum distance between intersecting lines. Can you graph vectors? I don't have an Nspire. I mean, you can do that, but when you have it on paper 1, you can't do that. Anyway, as a general rule of thumb, for when you're doing any question with a minimum distance, even if you have 2 lines, let's say you have a line L1 is equal to R of whatever, 3, 2, 1, plus, no, I can't be. I actually don't know how. 1, 2, 3, and L2 R equals 2, 4, 6 plus mu into 5, 6, 7, whatever. What you're gonna do is you know that the minimum distance between two lines is the perpendicular distance. So if we have L1 here and we have L2 here, keep in mind that these are going to take you to any point on the line. And we have to find the minimum distance, which is the perpendicular distance of the lines, between the lines, sorry. And the fun thing is that you here can use the parametric equations of these two lines to find the vector from any point on this line to any point on this line. So if we have, you know what, we can just do this with the question that I just came up with. It's probably going to give you some interesting numbers up. X is equal to 3 plus lambda is also equal to 2 plus 5 mu. You get it? Do I need to get closer? Can you guys hear me? Guys! Sorry, I don't know where the mic on my iPad is. My fault. Anyway, and y is 2 plus 2 lambda, 4 plus 6 mu. Oh, it's near the camera? Oh, that's why I was covering it. Z is 1 plus 3 lambda, or 6 plus 7 mu. Pretty good that you were asking. And now what we can do with these two is we can find the vector from any point on this line to any point on this line. So it's going to be 2 plus 5 mu minus 3 plus lambda into, sorry, and then 4 plus 6 mu minus 2 plus 2 lambda and 6 plus 7 mu minus 1 plus 3 lambda. Why did we equate the two? Because this is x and this is x. That's it. It's the x coordinate. So now we have the position vector from any point on this line to any point on this line. Well, first we have to compute it. So that's -1 plus lambda plus 5 mu. Fuck's sake. 5 mu. Alright, so you get. And then 2 plus 2 lambda plus 6 mu. And 5 plus 3 lambda plus 7 mu. There. Now, what we know is that because this is the direction vector of any point on this line to any point on that line, whatever, if we cross it, not if we cross it, sorry, dot product of this and the direction of either line will give us 0 because it's perpendicular. So this dot 1, 2, 3 has to equal 0. And same goes for 5, 6, 7. Now, when you do that, you can solve for lambda and mu simultaneously and then get the magnitude of this whole thing. But that kind of seems like a pain. I'm not sure if you guys want to do that right now, but that's how you do it. Same thing goes for just like a point and a line. Same exact logic. You can do it another way, I'm sure. This is just a way. Because no, maybe? Can you use the cross product? Sure, maybe. Why would you? Oh, you can, but it's this really, really like annoying way of doing it. And usually you have to like, here we don't have the values. If you have the values, like there is this really like mental gymnastics way of doing it where you like use the area of the parallelogram and then you find the height of it, but that's not worth it. The lines have to be skewed. Why? It's just the minimum distance between them. You can do it with the cross product because you can like get the area of the parallelogram and find the height over here, but it's really overcomplicated and I wouldn't recommend it. And general rule of thumb, if you have a line and you have a point and you want to find the minimum distance, or if you want to find the minimum distance between anything, honestly, minimum distance is the perpendicular distance. Are there other possibilities where they, well, yes, but if they're parallel, then you can still find the minimum distance between them. No issue there. They have to be parallel, actually. Or I guess they can be skew. Either way, they can't intersect. I mean, if we're not in 3D space, then we don't have to worry about skew lines. Anyway, minimum distance means the perpendicular distance. Yes, but let me finish my sentence. So that means dot product has to be 0. That's basically always your approach. You just want to equate the dot product to 0. That's the simplest way to do it. If you have a point and a line, what do? You find the position vector of any point on the line, which is the parametric equations, and then you find the vector. There is another way, it's just really overcomplicated. You find the vector from this point to the line, or sorry, from the line to the point. Then that dot, this is 0. There's a formula, but it's really bad. Guys, the other way to do it is really complicated, and it uses the cross product. Use the dot product. It's easier. Because, no, because the thing is, the way you do it with the cross product is really overcomplicated. Let's say we have a line, and this line is defined by direction vector AB 5, 6, 7. We have A here, we have B here, whatever. It doesn't matter. And we have a point C that's not on the line, and we want to find the minimum distance. There is a way you can do it where we know that we have, this direction vector, because it's just OC, right? It's from the origin to C. We can basically find the direction of C, cross it with AB, and then get the cross product to find the area of this parallelogram. And then you can divide it by, because we know that the area of a parallelogram is base times height, so that would be magnitude AB times magnitude of that, which is, this is what we're looking for, minimum distance. And so we could do area of the parallelogram divided by this, but see why that's really complicated? Don't do that. Use the dot product, just for your own, well-being. Also, do you guys have any just, general questions? Because I feel like we've done enough problems for today. Rundown of what? Minimum distance between two lines? I'm doing stellar, Hockey. I'm doing wonderful. Closest distance between two lines. Guys, we haven't done kinematics, but I feel like vector kinematics is pretty simple. Not a huge deal. We can do it at some point if you guys want to, but closest distance between a random point and a plane. Really easy. Because if you have a plane... Oh, sorry, wait. First, let me explain this question for this guy. Yes. I know. I was getting there. Don't worry. We have a line here, and we have a line here. With the parametric equation of the line, we can find the position vector of any point on this line and any point on this line. And by doing that, we can find the position vector of any point on this line to any point on this line. So, if we do that, we know that from here to here is perpendicular to this direction and it's perpendicular to this direction. So if we get the direction vector from this line to this line, we can do this dot that direction and equate it to 0 because it has to equal 0 because they're perpendicular. Or you can, and then you can dot it with this one and equate it to 0 because it has to equal 0. Then you can solve simultaneously for lambda and mu. I think they'd only put this in a paper too unless they have really easy numbers in it, or they're just trying to like kill you. Find cross product of both parametrics and find its dot product with the direction vectors. So why are we finding the cross product of the parametric ones? Not the cross product. Just the direction vector of this one to this one. Any point on here. This is the it is the position vector. It's the vector of any point on the line. Because it doesn't matter. Lambda and mu are different. Or no, basically this is any point on line 1. This is any point on line 2. You can find the vector from any point on this one to any point on this one, and it has to be perpendicular to these. So if you do this dot that, has to be 0. Alright, good luck, cool, you got this. No worries. Wait, does anyone want to know how to find the minimum distance between a line, a point and a plane, or do we get it? Cool, do you want me to explain it? Or did Patrick explain it? Alright. Okay, wait, I'll explain it for Doc. Minimum distance between a plane and a line? Yeah, that could show up. Anything could show up, honestly. Anyway, so let's say you have a plane pi. Where can you find these questions? A lot of them were on Andrew's paper. I'll send it in the math channel at some point after this. Well, yes, but I'm getting there, Burger Boy. You want to find the minimum distance between this point, A, and the plane. And the normal to the plane is perpendicular to the plane. So, and we already know the normal of a plane because a plane is usually defined by its normal, right? If we have a plane with Cartesian equation, ax plus by plus cz equals d, a, b, and c are the components of the normal to the plane. So, we can just set up a vector equation of the line, L, and we can have our fixed point as a here. So I'm just going to do OA plus lambda into our normal here, which is ABC. And what that's going to do is give us this line right here, which also happens to be perpendicular to the plane. And we can use the parametric equations of this line, so x equals whatever plus lambda whatever. And by plugging those into the Cartesian equation of the plane, we can find lambda, and then after we find lambda, we can substitute it back into this equation of the line, and it will give us the point of intersection right here. We can call that x. And then if we find vector ax, we can find the magnitude of that vector, which will give us the minimum distance. There we go. Does that make sense? All right, no worries. Thank you, Paradigm. Oh, you're graduating tomorrow. Fire. Have fun. All right, any more questions, guys, or do you want to wrap this up? No worries. Because it's the ceremony, not the actual thing. Oh, Thank you, Paradigm. Yeah, hopefully. Anyway, no more questions, right, guys? Or what do we think? Yeah, it should be it, unless anyone has a question. I didn't drink water. I should probably do that. This is referring to finding the distance between a point and a plane. All right, see you, Carol. Can I link the questions? Some of them. Yeah, I can send this thing. I mean, I doubt it's going to make sense without context, but I can send it if you want to look at it. All right, see you. You're welcome. All right, I'll send it. I don't bench. I'll send it. No worries. See you. All right, I feel like we're done for the day. So thanks for coming, and I'll probably just end it here. Thanks, I'll keep. No worries. All right, see you guys. I'm gonna